Hey everyone, welcome to my channel. So today I was getting very bored and I just thought to just discuss the question paper that we gave today for the AITS, that is All India Test Series from, you already know it. So let's see the first question. I'll say and answer we'll check, right? So in the equation P plus A by V square V minus B is equal to constant, the unit of A is. तो ये question कैसे करना है हम देखते हैं इसको. So take some blank part here. Yeah. So see here. How do we do this? So for this what we do is we just need to take P plus A by V square, and we need the unit of A, right? So this we need, isn't it? So this plus means P is equal to A by V square. Send that V square there. PV square is equal to A, and then you know P is pressure is force upon area, and volume is meter cube, L cube into 2L to the power 6. Okay, so force is Newton, that is M1 L1 T minus 2 into what? Into volume, that is L cube, and this is area as I said, so it will come up and it will become minus 2. So this will become 1. So it is asking, the question is in terms of dyne centimeter. Okay, so let's solve in terms of that. Force is dyne, and this is centimeter square, and because it is area, and volume is centimeter cube. Volume into 2, that is 10 to the power 6. Okay, so it will go up. So dyne centimeter to the power 4 is the answer. Okay, so our correct option, you can check here, correct option is 2, and this is the answer. Dyne per centimeter to the power 4. Okay, so let's see the next question. The question I will say, okay, the number of significant figures in this one. So as you can see, number of significant figures is, you don't have to count this zeros, forget about it. Count this 1, 2, 3, 4. So 4 significant figures we have. Yeah. Now a stone is projected. Okay, a stone is projected from the ground. So where is the stone? It is projected from the ground. Okay, with a velocity of 14 meter per second. 1 second later it clears a wall of 2 meter height. Okay, 1 second later 2 meter height it clears. Okay, the angle of projection theta it is asking. So how to approach this question? So how to do it? So what you need to do is you'll get answer as 30 degrees. Okay, how to do is, from the equation, this equation, y is equal to u sine theta minus half gt square. S is equal to ut, s is equal to plus half gt square, half at square. Since it is coming down, since it is going up, so we'll take it minus. Okay, it is going up, so we'll take minus, and we have to take vertical velocity, so it will become u sine theta. V is u sine theta, and half gt square minus you have to take because it is going up. So it's saying height is 2. 14 sine theta, that is velocity is given. Okay, with which it is projected is given, that is 14. Okay, and into 1 minus half. G is given in the question to take 10. Okay, so we have taken 10, and 1 second later, so 1. So if you solve, this will be what? 2 is equal to 14 sine theta minus, this will be 5, minus 5. If it go that side, that will become 7. 14 sine theta, so 7 the 7 into the 14. So 1 by 2 is equal to sine theta, and 1 by 2 sine theta, 1 by 2 is nothing but sine 30 degrees, and sine 30 degrees we got. So correct option is option number 2. So did you get the question? I hope so. Okay, next question is what? A uniform rod of length L lies on a table. So we'll take some space here. So this is a very interesting question, and it's a very common question. You will see. So there is a chain or rod. What is that? Rope. It is a rope. Okay, no problem. Rope is there, not chain. Rope is there. Okay, rope is there. It lies of length. Its total length is L. Lies on a table. If the coefficient of friction is mu. Okay, the maximum fraction length of the hanging part of the rope on the edge of the table without sliding down. So let's suppose the part which is on the table is let's suppose the part which is on the table is x. Okay, L minus, let's suppose C, this is the rope, this is the rope. Take with some other color. This is the rope. What is happening? So this is the rope. Okay, and what is happening? See, 1 minute, just a minute. This is the table, and this is the rope. Finally, so this is the rope. So let's take the hanging part as something. Let's say x. This part which is on the table is L minus x, of course, because total length is L. So now and there's a coefficient of friction. There's a friction also here. This is acting backward and preventing the rope from falling down. And we have to deal with in terms of linear mass density. So linear mass density is nothing but total mass by length. And if I want to find out about this L minus x, so I will multiply with L minus x. Let's say this m by L is equal to lambda. So lambda into this part, hanging part, first I'm considering this hanging part x, into g, gravitational force which is trying to pull it down, which is prevented by this part, mu, lambda x g, mu lambda L minus x g. This is minus, okay, L minus x g. Okay, so lambda is nothing but linear mass density, which is total mass by total length. Okay, so for x part I am taking, this is x, okay, and this is L minus x I have just multiplied. Okay, it is mu lambda L minus x g. That's it. Okay, if you check, you can cancel gg, you can cancel and even lambdas. Okay, so x is equal to mu into L minus x, isn't it? This is the thing. Okay, this is the result, but it is asking the fraction. It is asking what the question, it is given fraction of length, hanging part of the rope. So this is the we got. So let's convert it. Okay, so x by L minus a fraction of the length hanging. Okay, x by L is mu into what we got, L minus 6, right, by L. If we try to simplify it, how will you simplify it? So how will you simplify? See, here you can see how it is simplified. How it is simplified means, as we have taken L minus x by L, right? So can I write this in this way? Mu L minus x by L. Can I write this as L minus x by L? So can I write it as like mu can I write it like this, 1 minus 1 minus mu x by L. Okay, 1 minute. 1 minus x 1 minus x by L into mu. Can I write like this? Okay, and this is x by L. Alright, so if I convert it in some way, I'll get it as mu by mu plus 1. mu by mu plus 1 I will get. So this is the direct result also, you can remember. Okay. Next question says that this is a particle. A particle does uniform circular motion. It is doing uniform circular motion in horizontal plane. Okay. The centripetal force acting on the particle is 10 newtons. This is 10 newton. Its kinetic energy is 1 joule. Kinetic energy is how much, guys? Only 1 joule. The radius of the circular path. So I have to find the radius. So if you check what is centripetal force, mv square by r. Okay, mv square by r. We need to find out the radius. How do we do that? So mv square by r is equal to 10. mv square is 10 r. We need to find out r. You know, from kinetic energy, half mv square is 1. Okay, half mv square is 1. Let's find out the value of mv square. That will be 2. Okay, so this is 2 by 10. This will come there. 2 by 10 is r. So r is equal to 0.2. Okay, so the answer is 0.2. Okay, it's correct, guys. 0.2 is correct. But let's move to the next question. A uniform cylinder of radius r. There is a uniform cylinder. The radius of the cylinder is how much? R. Length of the cylinder is L. Mass is m. It's lying on the ground with the curved surface touching the ground. This part is touching the ground. If it is to be oriented on the ground with the flat circular end in contact with the ground, the work to be done is how much work you will do to make it to stand like this. Okay, so if you see, the initial height is how much from the ground? It is just radius, right? R. Final height, if you check, you have to take center of mass. Okay, that will be L by 2. Change in potential energy will be how much? So m, before it was mgr. Okay, first we'll write final one, mg h, right? Potential energy. L by 2 is the h minus mgr. So if you subtract this, take mg common, so L by 2 minus r. It's a simple question only. Okay, so this way you need to do. So the correct answer will be mg L by 2 minus r. Let's discuss the 7th question. This is a pump motor is used to deliver water at a constant rate, certain rate, from a given pipe to obtain twice as much as water from the same pipe in the same time. Then the power of motor has to be increased to 2. So you need to find out the relation between, guys. Please stay connected with our channel. We'll be going to upload lots of important videos. Like we will be also uploading Akash All India Test Series and also Major Test Series, LN, and even that one, Motion Institute. So all institutes will be doing. So stay connected. So if you'll see here, there's a motor pump. It delivers water at a certain rate to given pipe, and to obtain twice as much water from the same pipe in the same time, how much power I should want. What it is saying just simply, there is a motor pump, and we want double the water what it is giving now, and it is in the same time. But so I have to increase the power of the motor. How do we do that? Power is nothing but force into velocity. Okay, or else you can also write half mv square in this case, half mv square, because it is pumping the water. But general formula is Fv, but in this case we are modifying the formula into half mv square. So half, and if you write mass, you will get a v rho into v square, because you know mass is density is mass by volume. Then mass is rho v, isn't it, guys? Mass is rho v. Can I write volume as, can I write it as what we got, we got just now rho volume. So I'll write rho A and length, isn't it? If I take mass per unit length, mass per unit time, okay, so I'll divide this by time. This will become velocity, so rho AV, isn't it? This is also velocity. So now it will become v cube. So if I want double mass in the same time, then what should I do? Power is directly proportional to v cube, or else from this and this, if you relate, you can get that mass is directly proportional to v cube. If I want m by 2m v by v dash whole cube, this cancel. 1 minute. If I want double mass, so what should I do? I should cube this velocity, then I should if I want double mass, right, power is directly proportional to mass is directly proportional to, inversely, what is that? 1 second guys, here we'll check it out. So to get double amount of water, velocity should be double, hence power becomes 8 cube. So to get double water, m is directly proportional to v cube. So I want double, right? I want double. So here it will be also double. So power will become 8 times. Okay, how do we do that? Once I got this, but now I'm not getting ISO. If I cube this, I'll get 8, right? So it will become 8 times. But yeah, see, mass is doubled, right? Mass is doubled, and mass is directly proportional to v cube. So I have to cube this velocity. So 2 cube, if you'll take 8 times, so power will become 8 times. See, if the motor pump water density is this continuously through a pipe of area of cross section A with velocity v, then mass of flowing out per second is ma rho v. Rate of increase in kinetic energy is equal to power of the pump. So this is the thing. So if you cube that mass, you'll get, see, 2 cube, get 8 times. So power should be increased 8 times. If you want double, then if you want double mass in the same time, then you have to get power of 8 times p. If you get 3 times, then it will be 3027 p. Like this you need to do it. Okay, so you need to remember that mass power is directly proportional to m cube. Directly proportional to m cube. Okay, let's see the next question. Question is that an object is there, guys. So there is an object is there. Its mass is how much? Its mass is 20 kg. Okay, it is moving with some speed 10 meter per second in west direction. Another object of mass 10 kg in moving with 15 meter per second in north direction. Both collide and stick together. Choose the correct alternative. We have to choose the correct option. Okay, so what they are saying, there is a mass that is 20 kg. It is moving with 10 meter per second in west direction. West means this side. With velocity some 10 meter per second. Other object is there of mass 10 kg moving towards north like this with how much? 15 meter per second north direction. Both colloid and stick together. See, if they are colloiding and sticking, it means it is perfectly inelastic, like bell stick pendulum. Perfectly inelastic means what? Only momentum is conserved. No, kinetic energy is not conserved. Okay. So when object of mass 20, and they will move with common velocity after sticking together. So solution: 20 kg moving with speed 10 meter per second in west direction collides with object of mass 10 kg of mass of both of them stick together, hence it is perfectly in elastic collision. Only momentum is conserved. See, in elastic collision only both are conserved, others inelastic. Okay, so what is this? Okay, so let's see the next question. Next question is what? Next question is if 27 small spheres, this is very interesting question. 27 small spheres are there, each of moment of inertia I about the diametrical axis are combined to form a big sphere. The moment of inertia of the big sphere about its diameter. About its diameter is how much? This is a very interesting question. I really like this question. So see, it is not going. What should I do for this? It's coming again and again. What should I do? Anyways, I have to bear this. Okay, so if you'll see the solution, I1 is 2 by 5 mr square for sphere. So you need to remember that we are considering it solid sphere. And how do we remember it is solid sphere? See, 2 by 5 mr square, 2 by 3 mr square, get confused. 2 by 5 mr square is for solid sphere. S for solid, and in denominator take 5. Okay, and solid sphere, this is mr square. Okay, mr square is moment of inertia, 2 by 5 you have to add, and 4 by 3 pi r cube is the volume, because volume is conserved, right? So according to that we are doing. So there's a relation, guys. You need to remember this relation. Relation is r is n to the power 1 by 3 r. So remember this relation. So if you put 27 here, so 27 to the power 1 by 3, so 3 to the power 3 by 3, so this will be 3. So r is equal to 3r. What they ask, moment of inertia about the diameter. Check it here, guys. So what is they saying? Yeah, so if you check here, what is this hell? Why it is not going? Okay, finally I managed it. So see, guys, so we want what? We want moment of inertia of the biggest sphere about its diameter, right? So if you see, I dash is how much? 2 by 5 mr square, right? So we now know that mr square, capital R is 3r, isn't it? From that relation, that is n to the power 1 by 3. Guys, relation is very important. Remember this. I'll give a lot of relations to you in this session, so it will be very important. For potential also, n to the power 2 by 3. So we need to remember all this. Okay, so we'll discuss in detail, okay, and the question itself. Okay, so from there we got 3r, right? If you square it, because square is there, mr square, so you can write here, because 27 as it is, so this will become 243i. So this is the very important question, guys. So do it, learn it, understand it. What you need to do is, I dash is for solid sphere 2 by 5 mr square. Instead of m, I'm taking 27m, because there are 27 small spheres, so I have to take 27m. And what is that? Into 9r square. So this part, and this part is what? I. So 27 into 9, you have to do 7 9s are 63, 9 is 18, 243. So 243i. So this is the question. It looks difficult, but it's quite easy if you remember the concept. So you need to remember that for ring, the moment of inertia is mr square. For disc, mr square by 2. Okay, and others are also there. Okay, 1 minute, guys. After drink some water. So this is the thing. Next question. Let's do it fast, guys. So the next question is, if a body weighs how much? 72 newtons on the surface of the earth, what is the gravitational force on it at a height equal to half the radius of the earth. So the question is, a body is there on the surface of the earth, its weight is 22 Newton, and we took it to some other planet. No, we took it to we took it to the height that is equal to the half of the radius, and we need to tell what is its weight there. Okay, if you go into mountain, your weight decreases. Let's see how. So mg is 72 on the surface of the earth, and you know g dash is nothing but g by r. What was the relation you can see here, it's given. So g dash is r by r plus h whole r square. So actually the relation is c dash. What I remember is so here what is there here, g dash is what, g by 1 plus h by r whole square. This is the formula what I remember, and I did this question with this formula only. So let's see how it works. So if I send this here, it will be the same thing, guys. So g dash by g, writing very big. Okay, my tab is small. Okay, so this will be how much? 1 by, h is given 1 by r, so I'll be using how much? Half of the radius of the earth, r by 2r whole square. This r cancel. So what will be remaining? G dash by g is, did you remember what was there? 1 plus half whole square, 3 by 2 whole square. This will be how much? 3 by 2 whole. G dash by g is 1 plus r by 2r whole square. This cancel. So this will become 3 plus 1, 4 by 1 minute. So this will be 1 plus 1 by 2, 2 plus 1, 3 by 2, 3 by 2 whole square. Okay, 3 by 2 whole square. So it will go up because it was 1 by 3 by 2 whole square. If it goes up 4 by 9. Okay, so this is the thing. F dash is mg dash m. So if you write the new force, the gravitational body weight, that is, if we talk about the weight of the object, so mg dash, it will be how much, guys? M into 4 by 9 g. 4 by 9 g. So this will be 4 by 9 g. So we already know mg is 72 newtons. So 72 into 4 by 9. 9 8s are 72. 8 4s are 32. So the answer will be 832 newton. Did you get the question? The question was mg is equal to 72 newton. That is given. We need to find out at a height h by r by 2. R by 2. So for that we need to first calculate at r by 2 what will be the gravitational force. Then later we'll find out the new weight of the body, and we already know mg, so we'll substitute that. I hope you got. So if not, you can connect me on Instagram also. I'll give the link at the end of the session. Okay, so let's see 11th question. A simple harmonic oscillator has an amplitude A and time period t. The time required to travel x is equal to a to x is equal to a by 2. This is from SHM, and SHM make us fear a lot. Let's see about this question. So you have to, there's an, for amplitude A, the time period is t. Amplitude is A and time period is t for the SHM. Okay, so a to a by 2 you need to tell. Okay, let's see. X is equal to a sin omega t, a sin 2 pi by t into t, because omega is nothing but 2 pi by t, so we have substituted there. Okay, so this is the general equation. X is equal to a sin omega t. Now a by 2 in the place of x, a by 2 we are writing, so a sin 2 pi by t into t. So this a cancel. So if you see, if you check it out, half is equal to sine 2 pi by t into t. So if you see, when is sine half, it is sine 30 degrees, isn't it? So sine pi by 6 isn't it guys? Pi by 6 is 30 degrees. Yeah, pi by 6 is 30 degrees. Okay, sine 2 pi by t into t. So this question is very important guys, so be careful here. So pi by t. Okay, so now then what we can do, we can just can cancel something here, sine pi, sine this one, and this will be t by 6 will go there, so this will become t by 12. So t will become t by 12 for what guys? We have taken a by 2 for a by 2. Similarly, if you keep x is equal to a, so if you keep x is equal to a, so a sine 2 pi by t into t, a cancel. Okay, so this way we can do it. So I think you got. Anyways, so if you'll check this, okay, so if you'll check this for here 1 sine 2 pi by t by t. So this when do you get 1, that is sine pi by 2, sine 90 degrees, sine pi by 2, sine pi cancel, t by 2, t is equal to t by 2 we got. How much unit? Pi is sine, pi is nothing but 180 degrees, pi by 2 is nothing but 90 degrees. This 2 we forget it, so this 4, t is equal to t by 4, t by 4, t is equal to t by 4. Now let's subtract it. So t by 4 is greater, so hence t by 4 minus t by 12. So this will be how much? It will be 12. See, you can take this like this, simple thing, I'm teaching that also. 4 3 is 12 only, so directly you have to take 12, but I'm showing how to do that, even if for the people who don't know. Okay, 4 is 12, 3t minus t, that is 2t by 12, 2t by 12, 6 is 12, t by 6. So this is the thing. Let's see the next question guys. The question is, the stress versus strain graph of wires of two materials A and B are shown in the figure. So there's a figure. If Ya and Yb are the Young's modulus of the material, then see the graph is I'll show you. Okay, graph is what? Graph is like this, and this is A and this is B. So A, B, this is X, this is Y, this is nothing but stress and this is nothing but strain. Okay, strain, and this is stress. So this is 60 degrees and this is 30 degrees. So you know stress by strain is Y. According to Hooke's law, stress by strain, Y axis by X axis, stress by strain. This is nothing but tan 60 is given. Tan 60 is how much? That is root 3, and this is tan 31 by root 3. So root 3 into root 3, 3. So Ya is equal to 3 Yb. So fourth option matches, isn't it? Yeah, check it out. Let's see the next question. It is also a very important one. There is a capillary tube. There is what? There is a capillary tube. R is immersed in water and water rises to the height of h. Okay, the mass of the water that will rise to this tube if you double the radius. So you need to remember h is equal to 2t cos theta by rho rg. So this is the radius. Okay, 2t cos theta by rho rg, and this is your what? H. The mass we have to discuss in terms of the mass. So here density is there. Can I convert it into mass? Yeah, density is mass by volume. Second right, mass is rho v. So rho v. Okay, so mass is rho v. So if I substitute in the equation guys, so so what you're getting, you'll be getting like h is equal to 2t cos theta by, instead of rho mv we'll write rho v. Instead of rho, we'll get mass by volume. So volume will be here. This is mass into rho r g. If you check this, h is inversely proportional to r mg. So then you can write r is inversely proportional to, r is how, mr is constant, right? M is directly proportional to r. Proportional to r. So you can write, if radius is doubled, then mass will also be double. So if it was m was 10, now it became 20. That is the thing. So here they have given some other explanation. You can see this is the capillary tube first of all. So t cos theta into 2 pi r is mg. So we can see r is directly proportional to m. And this relation also you will get. Here I am not getting proper space. So try to get 2t cos theta by rho is mass by volume. Mass here volume r g. So guys, if you write volume, that is 4 by 3 pi r cube. So this cancel, this is square, right? Here 2t cos theta is there. 2t cos theta, tension is nothing but force upon length. So here r square, this cancel. So mass, if you send this side, so m is directly proportional to r. Okay, did you get that? I hope so. Let's see the next one. So if you just remember that if you double the radius, you'll get double mass. That's it. Let's talk about important thing, that is very simple thing. If you see this, Boyle's law is there. Boyle's law says that P is inversely proportional to V at constant temperature and mass, fixed mass, okay, certain mass. So you'll say PV is constant. So then you can say that P1 V1 is equal to P2 V2. Okay. Let's see next one, Charles law. Charles law is nothing but it talks about what? It talks about volume and temperature. Charles talk about volume. Whereas Gay-Lussac, it is concerned with pressure, is directly proportional to temperature. So Gay-Lussac is concerned with pressure directly proportional to temperature. Okay, isn't it? Pressure is directly proportional to temperature at constant volume. So if you talk about Gay-Lussac, it is more bothered about pressure. If you talk about Charles, it is more bothered about volume. So how to remember? People usually get confused about it. So see, Charles law. Charles, VC is for Charles, V is volume. Gay-Lussac, GP. Remember GP, G is Gay-Lussac, P is pressure. Okay, like this. Another is also there. Equation of gas of an ideal, equation of state of ideal gas. So we know PV is equal to nRT. That is, we already know. What we don't know is PV is also equal to NKBT, where what is N? N is nothing but, you know guys, small n is equal to N by Na. PV is equal to nRT. Here R by Na is nothing but KB, Boltzmann constant. So instead of R by Na, we'll write KB. Okay, is it okay? A black body radiates heat in what? All possible wavelengths. Black body in all possible wavelengths. Okay, let's talk about black body is what? It discontinuous. It is related to chemistry. Discontinuous emission. Okay, discontinuous emission and all possible wavelengths. All possible wavelength. Okay, for what? Black body. Okay, there is a graph given, check it out. So see what they give explanation, check it out. The radiation from a black body consists of all possible wavelengths. work done area under the curve. So see, look at this question. So this is the curve given, this is pressure, this is volume, PV curve, the area under the curve, like this it is given. This is 1, this is 2, this is 3. So this is the one area. I'll draw with different colors. So for the first one we'll take green. Okay, so this is first one, and second one is already red, and third one will take blue. So this is, so if you'll check, third one is having greatest area. So if you check, third one is having more work done, like this. A3 is having more, so work done in A3 is more the area, more the work done. Next question, let's see. Next question, this question is very interesting. It's a previous year question also. What is happening in this? Okay, so the efficiency of an ideal heat engine working between the freezing point and boiling point of water is. Freezing point and boiling point of water. So guys, look at this. Freezing point of water is how much? 0 degrees Celsius, that is 273 Kelvin. Okay, agreed, isn't it? Boiling point of water is 100 degrees Celsius. If 100 degrees Celsius is there, guys, so 100 plus 273 is 373 Kelvin. Okay, now 373 Kelvin, 273 Kelvin. So source is 373 T1 and sink is T2. So T2 is 273, T1 is sink temperature 373. Efficiency is nothing but percentage efficiency they are asking. So just 1 minus T1 minus T2 by T1 into 100. T1 is 373 minus 273, 100 by 373 into 100. Okay, so if we'll do this, so 100 into 100, this is for percentage, 373. So this is nothing but 1 2 3 4 zeros by 373. So 1000 is there, so 373 3 if you do 9 23 21, this is a 9 10 11. So this is more than 1000, so you have to take 2, and then if you solve further, this I took for only 3 digits, right? So if you'll get something remaining, and then we'll get 26.8 percentage. So this is the thing you need to do. Okay, let's come to the next question. In this video we'll be only doing up to 20 questions because video is already very long. The ratio of specific heats at constant pressure Cp and volume CV constant volume CV is 9 by 7, and the number of degrees of freedom. So I have to find out degrees of freedom. How do we do that? So 1 minute. Okay, so Cp by Cv is how much? You already know it, 1 plus 2 by F. Gamma is nothing, 1 plus 2 by F. This relation is very important, do not forget it. Okay, don't forget about it, do not forget. Cp by Cv is nothing but gamma is 1 plus 2 by F. You need to find out F. Cp by Cv, gamma is already given, that is how much? 9 by 7, which is 1 plus 2 by F. So 1 plus 2 by F, gamma is 1 plus 2 by F. So if you send this side, it will become 9 by 7 minus 1. So 9 minus 7, 2 by 7 is equal to 2 by F. To cancel, F is equal to 7. So the correct option is fourth option, that is 7. So this way you need to do is, Should I repeat once again? It is very simple. Cp by Cv is nothing but gamma. Gamma is 1 plus 2 by F. You remember this formula at any cost. That is gamma is 1 plus 2 by F and gamma is Cp by Cv. C by Cv is already given. Gamma is what? 1 plus 2 by F. F is your freedom. It's 1 plus 2 by F. Okay, remember this, 1 plus 2 by F. Then another question which is Very interesting, really, it's very interesting. Some Doppler effect. If an observer is moving with uniform velocity v naught towards a stationary source of frequency n, if the velocity of sound in the medium is v, then the apparent change in frequency of the sound heard by the observer. So what they're saying, so there is an observer who is going towards the source. Maybe the source may be playing some songs, so the observer is moving towards it to listen it. The frequency of the source sound is n, and sound in the medium velocity is v, and observer velocity is v naught. So apparent is see, keep it aside, I will say you how to do it. So apparent is what they are asking. First of all, they are asking change in the frequency. They are not asking frequency, change in the frequency. Frequency is nothing but apparent frequency. This one is given v plus v naught by v. If you don't know this, I will explain you in my video. But now, as if now it is very long video, so I cannot discuss it. So this is the thing. This they have given. Okay, I am rewriting the equation. New apparent is n v plus v naught. Observer is at rest, so 0, so v by v. So how to write this type of equations, I will teach in another video. So please comment in the comment section. I'll definitely make sure that I'll make that video. Okay, so this is the thing. So so they are asking change in the frequency. Change is fine, initial minus final. This is the final, right? V plus v naught by n. So can I write it this way? 1 minus v plus v naught by v by n into n. Can I do it? Yeah. Yes, isn't it? So I can write. So I can write this way: v minus v plus v naught by v. So v minus v plus v naught by v by n into n. This cancel. This one is there. Sorry, this one is there. This one is there. So this is v naught n by v. Okay. So here you can see the explanation. See, similar way they have to change nothing but change is nothing but final minus initial, apparent minus this one. This is the change. Apparent minus actual. This is the apparent, this is actual. So if we'll do this one, nv plus nv. So we'll write this like this: nv plus v naught by v. This is minus nv plus nv minus nv cancel. So nv naught by v. Change means final minus initial. That's it. The last question we are going to discuss for this session. We'll continue the 50 questions in another lecture. Okay. Remaining questions are very interesting, so don't miss it. The electric field. What they're asking is the electric field at a point on equatorial line of dipole and direction of the dipole moment. Electric field at a point on equatorial line. Equatorial, they're saying. And that is also dipole direction. So they're asking about direction. Direction of electric field at equatorial point A and B will be in opposite direction as that of the direction of dipole moment. So dipole moment is always from negative to positive. So the direction of electric field at equatorial point A or B will be in opposite direction as that in the direction of dipole. Dipole is here, so electric is here. Dipole is here, electric field is here, opposite. But in case of axial, both are in the same direction. Dipole and electric field. Remember this, guys. Understand it, remember it. Okay, so we have done 20 questions. Remaining 30 questions in the next lecture. Thank you so much for watching.